Alright, welcome back to simulation and prototyping. I want to pick up on the previous tutorial, but add a little bit more precision this time around. And so in the previous tutorial, we had two circles moving kind of independently. They produced some erratic geometry. There are moments when you're going to want to use this as a design tool to prototype some ideas and not be sure what you're going to get, and you might like that. There's other moments where we want to be really precise. And so what I wanted to do is balance these two and show you a different example. We're going to use the type of geometry that we're talking about here is an epicycle. And this is a geometry that's rotating around other geometry, like the solar system or like spirograph. So maybe some of you played with spirograph when you were a kid. The other thing is that there's a geometry called a cycloid, which is that if you pick a spot on a wheel and you roll that wheel one full rotation, it produces a kind of curved arch form. And I'll show you an example of this in the lecture. We're going to take that one rotation and wrap it around our other. And so that becomes an epicycloid. And so here's an example of this from the rotation. And so as we move to the 12 o'clock position, you'll see as the outer circle rotates around and we track that point, its rotation produces that cycloid. And so in this case, the smaller circle circumference is 1/3 the size of the overall circle. So the big radius is 15, the small radius is 5. This means it produces 3 rotations around. We can change these things. Right? We could make this small, we can make the small radius large, and we can see the way that some of these things change. Have multiple rotations around that, like the spirograph. So we'll do that. And there's also another example where we just set the frequency of the rotation of the orbiting circle at a faster rate, and that will produce more of a kind of spirograph example. So I just want to work through building these to give you a little more practice in terms of thinking about how we put components together. And again, we're starting with a really simple thing that just is one circle rotating around another circle, but building this kind of algorithmic thinking related to this. So I'm going to start with a new file. I'm going to work in large objects feet. I'll select the top view, and I'll do a new Grasshopper file. Okay, and let's start with a point. Shorthand here, because I've got completely fresh files, why not just work at the origin? I can just select my point, type 0, and then enter. This is now the origin, 0, 0, 0, but in Rhino shorthand we can just type 0, which stands in for 0, 0, 0. We'll make a point container by searching for point. We'll right-click it, set one point, and choose that point. Because we're not going to be moving this point around, we can hide the Rhino geometry, which will just leave us with the Grasshopper geometry. So we have our point in space. Let's go about making our circle. So I'll search for circle, and I want to just do the circle that's the base plane and the radius. It comes in with a plane and it comes in with a radius default set to 1. Let's set this radius. I'm going to use my shorthand again to make a slider, and let's say the range goes from a minimum of 5. We'll have our starting condition be 10, and we'll have it go to 20. We can always change these things later, but we'll set that to be the radius. And I do, because there'll be moments when you don't want to work at the origin, I'll just create my own XY plane. This way I can hide it, and we can also have that control and that understanding of it. So we'll set that for the plane, and we'll hide that plane. So now we have our circle. Like we did before, let's create our point in space. We'll create a line, and so we'll be able to visualize that as it rotates around. So we'll do a move, because we want to move this point vertically in the y direction. So I can also get a y vector. And we know that we want to move it the same amount as the radius, so we can make double use of this slider. We'll set the y vector for the move, and then we want to move our first point. So now we have that. We can create a line, search for line, and I want the line created by 2 points, 2 endpoints. And these 2 endpoints will be our first point and our point that was just moved. So now we have that. And let's see, let's look at just simply rotating this circle. So I want to create another slider. This time it'll go from 0. We'll start at 22 and we'll go to 360. We'll name these in a second so we can keep track of them. So let's do a rotation. Rotate. We'll rotate an object with a plane. The plane this time will be our same XY plane that we were using. Oh. And we want to right click on angle because the default is radians, and none of us are really used to working in radians, so we'll change this to degrees. We'll use our slider from 22 degrees to rotate that, and the geometry that we want to rotate is that line. And just like last time, this is rotating counterclockwise. I want to be difficult and I want to work in clockwise, so I'm going to right click on angle and I'm going to give it an expression. The expression defaults to whatever's coming in as x, and so I want to do x times, and in this case with this syntax, times is the asterisk, minus 1. Any number we give it from the slider, it'll turn it into the negative, and we can see that just flips it around, and that's fine. Move our slider, we get 1 full rotation of that line. Okay. Now, let's build our second circle that's going to rotate around that. We'll do it much the same way. We'll start by, let's displace or move this point to become the center point for that circle. You can see I'm moving left to right, but I'm also kind of moving up or down, just trying to keep the wires clear so I can see what's what. So we'll move. And in this case, we're also going to move y, but we're going to move the direction of the radius, and maybe now is a good time. We'll set the radius that we currently have to be radius inner. And let's copy it and rename this one by double-clicking it, and this will be radius outer. And I do want this one to be a little bit smaller, but let's set it to 5. That'll be good. It'll be half the size. That'll be easy for us to calculate a couple things in a minute. Okay, so let's move, and we're going to do the same thing. Let's copy our y vector. We'll multiply that times our radius, and we'll move this object. Let's see, what do we want to move? We want to move that point, so we'll grab that and plug that in. So now we have a new point in space. Yep, and that moves as we move that slider. So that looks good. Let's add a new circle. In order to do that, we're going to need a plane, and that'll be an XY plane again. And that XY plane will be based on this point. And circle again. That's our plane. And our radius will come all the way from over here. I like having the sliders kind of all the way to the left, so that when I come into a file, I can see that those are the kind of inputs and parameters that I'm working with. Our circle is there. I'm going to hide this plane. And again, I'm just going to keep moving the sliders, making sure that things are moving the way that we want them to. All right, so we have this circle. Let's add one more. Let's add our line here, just as reference as well. This will be a line between 2 points, and it will go from that point and this point. So we have this. So now as we rotate that circle, we can get a sense for that rotation. Okay, and we do have, let's, while we're here, rename angle. And I want to call this animated rotation, just because that's the slider that we're going to use to be rotating things. Okay, now let's start by just rotating the outer circle around. And so with that, and I might want to treat those different geometric elements separately. So let's start with our rotation. Rotate. And that is where we want the plane. Let's reference our old XY plane over here though. Plug that into our plane. It's getting a little messy. Not sure where it's best to do that, but we have that. So we have a rotation. Let's go in here, same thing, we'll right click, change that to degrees, and let's plug in our animated rotation again. Doesn't have any geometry yet. Let's give it this line and this circle and that point. And we can do this by holding down Shift, and we'll add these in. And don't be alarmed, it flipped around. We just want to add this expression again. I always have to be so careful doing that. So we're going to do x times -1. And now it flips over to the other side. So with that highlighted green, let's move our slider once more. Yep, that's moving the way that we want it to, or at least to start. It's just simply rotating that circle. Looks a little bit like Mickey Mouse, but simply rotating that circle around the other circle. So position-wise, it's right. Rotationally, what we have to do is we're going to want to rotate that as it moves around. And so we're going to add a rotation to this rotation. And let's see. So we will rotate. And again, to remind you, if you want to figure out where these are, if you want to find them another way, if you hold down Control and Alt and click and hold your left mouse, this will tell you that move is under transform and it's a Euclidean transformation. So any of the objects that you see, if you can't search for them, they're easy enough to find through the other menus. Okay, so we have this rotate. This time, what we want to do is we want our moved. You know what, let's do this. Let's break this apart because I do want to reference just the center point. And so let's copy it 3 times because we have 3 objects here. And let's just separate them out. So the top one will be, and I'm holding down Control to get rid of some of these. My top one is going to be just the point, which is coming from this move. The second one, I want it to be the line. So I'll pull out the circle, pull out the point. So now it's just this line. And then the last one I want to be is just, the last one that I want to have there is just the circle. So I'll eliminate the line. Again, holding down Control to do that. And so now we have these as three separate objects. So for the rotation, here's our point. That's our geometry for our plane. Oh, sorry, we need to make an XY plane. Skipped a step there. So that's our center point. That's our plane. We can hide it. Then we'll set our angles to be degrees. And our geometry now, we want to be our line. So we have that. What we need is the right rotation. You can see, I think that's defaulting to what, 1.5 pi. So we want to rotate this, and I've got an expression, and what we're going to do is we're going to manipulate the fact that we're going to use this animated rotation here. As we rotate this around the bigger circle, we want to multiply this by another number related to this step within here. And so the thing that we're going to do is we need to figure out the ratio or the relationship between the small circle and the big circle. So we're going to divide we're going to put the small circle radius over the big circle radius, and then we're going to multiply this by 360. So the way that we do this is with an expression. So I'll type expression, and this allows us to type in a formula here. And so let's set the smaller radius, the outer radius, to x, the bigger radius to y, and if we double click within the formula, we can wipe this out, and let's just say that x divided by y times 360. And you can look up, if you're working with different types of equations, you can look these up online, or you can try and work through them yourself. So we can see that x coming in is 5, y is 8. Let's change this to 10. The reason why I want to do that is now I know that the radius of the outer circle is half that of the bigger circle. So this is going to end up being, you can see the result here is 180. This means that the outer circle is going to rotate one entire revolution as it gets halfway around the outer circle. And so I think we can plug this into here. And so now as we increase x and y, it's not rotating the way that we want it to. I think I have to do one more step, and that is to then divide this. So let's do one more of these expressions. Control. And so let's plug in the result of this as x. Actually, you know what? Let's just do a division. So double click, say divide. So division. And what we want to do is we want to divide 360 by that result. So we'll set A as 360 and divide that by B, which is this result. It's also not rotating. Let's see. Why is that? Two. That's 180. Oh, that would result in 2, and that's not right. So okay. So this gets us 2. 2 means that as the other one gets to 360, it wants to rotate around. So what we then want to do is, because we're not actually changing the rotation, so now let's multiply. So multiplication, we're going to multiply that times our slider. So while the outer circle is half the size of the inner circle, it has to rotate twice. So no matter what value we give it from the rotation, we're doubling it now. So now we'll plug this in. That looks better. And so what we'll end up with is this, except we're rotating clockwise instead of counterclockwise. So we know how to change that. Right click on the A, change the expression, and set this to be x times minus 1. Okay. Let's try it again. So we'll go from 0. This will rotate around. As it gets to the halfway point at 180, it's made one full revolution, and then it comes all the way back around. So that's working. What we want to do now is we want to get the end point of this line so that we can then have an interpolated curve like we did before. So we have that rotation, which is that line. We can select endpoints from the geometry. It gives us both, but then we can do a point container, and this will allow us to select whether it's the start or the end. In this case, it's the end. So we can hide both of those, and now we have that endpoint. And let's just continue to track that endpoint as we rotate around. And again, if we change the radius of these circles, this will change how many rotations this will move around. So watch what happens now as we change this, and we begin to animate this. There's one rotation, second rotation, third rotation, and then a little bit more. And so by playing with these expressions and these variables, we can test different configurations. And this is, again, one of the things that I really want you to explore this semester, is using variables, we can start to explore a broader design space. Okay, so we have that animated version of this. We see that that's working, and that's fine. I want to hide my set of circles, or my set of geometry that's on the perimeter. I can also hide my static geometry that I was using as reference before. So now we have that. I like this, it looks good. We can see the way that that's moving around. Great. Let's do our same trick as last time, in that we're going to copy all of these things. I'm going to shift a little bit again, because I want to leave my sliders here, and anything that's referenced from the slider, I want to be able to take that and think I don't want to replicate these, so let me also move this off to the side. Separate these a little bit. Control C, Control V. We'll pull this down to the bottom. That's a little too far. Okay, so remember what we did last time. We want to maintain our ability to animate this, but we also want to get a range of possibilities for all of those points so that we can interpolate those points. So the way that we're going to do that, and again, as we change our parameters here, we want that to affect all of the other geometry too. So last time we used a range. Let's set that up again. I'm going to double click, type range. And then with range, we want to get, we want to construct a domain. We'll plug that in. The number of steps here is pretty arbitrary. Let's say that we are a minimum of 10. Let's start at 50. Let's go to 300. We'll plug that in here. And what we need to change is our domain to go from 0. Let's start with going to 360. We'll do one rotation. To really get a kind of spiral graph, we may increase this later, but for now we'll set that to 360. So any value that we had there, we want to now set up. And so because the x and y coming into this expression are coming from the radii, we're going to leave that alone. This one is tied to 360, but this multiplication comes from our animated slider. So I'm going to swap out B for my range. Okay, we'll take a look at that. Do we want to do that? I don't think we wanted to do that. I'm going to undo, and I want to duplicate that one. So it'll still come in here. We'll just separate some of these things out. We'll bring in our range to B, but we'll also disconnect this from this rotation, and we'll add in our new rotation. There. It's not looking right yet. Because we also need to rotate all of the other objects. So that was the second one. We need to now bring any of these lines that are dropping down to any of these 4 rotations need to come from our range now. And those should be easy to replace. Easy. Let's see, is this one tied to it? It is. So we'll take this range, we'll plug it in here. Here. It's a little crazy right now. And here. And here. Okay, so now we have a whole bunch of extra rotations. It's going to be even hard for us to see where our original one is. So let's hide some of these for now. Zoom in. I'm going to hide anything that's in the bottom, actually except for our last points. I can window all 3 of these, middle mouse, hide them. We can start to see the cycloid that's developing here. And it's nice to see the radius, but we can hide that as well. So now we have our points, Let's do the same thing. We'll interpolate a curve. It's just simple interpolate. And all we have to do is feed our points to that. We can hide our points. Now, let's see what happens. I'm going to come all the way back to our animation and make sure that this is tracking it. Starting at 0, 1 rotation, second rotation, and there we go. We can increase the steps. We can see that it's a little bit janky around the edges, and the reason for that is because of the interpolate curve. So watch what happens if we turn our points back on. We can see how it's interpolating these and where there's extra points and where there's not. So let's come back and we can increase the number of steps. Again, increasing the steps doesn't change the domain, the min or the max. It just increases the number of points in the middle of that. And maybe if we want to see that, we can add a panel. Again, panels are really helpful to see what is happening with the data. We can use them temporarily, and we can also keep them here. Right? So we have 50 steps from 0 to 360. I just want to increase this. We see those points being added. And now we get a nice smooth curve. Probably don't want to go too high. Maybe about 150 looks good. I can delete the panel. And let's take a look at that. Maybe let's hide the points again. And we'll animate it. That looks good. Now take a moment, as you're building your own, to just change the inner radius. See what starts to happen with that.